I'm very excited to introduce this series of tutorials from WiseOwl Training, which will teach you how to program in Python. At any point you'll be able to click on the link which appears at the top right of your screen to download code examples, useful resources or exercises to do with the video you're currently watching. And with that, I think it's time for my avatar to bid you goodbye so that you can concentrate on learning Python. So here's what you'll learn in this tutorial. We'll begin with installing Python, how to get it on your machine. We'll look at command line programs where you can run single commands in Python. We'll then go on to look at creating file programs where you can execute a series of commands. We'll look at the all-important topic of using variables. We'll take a brief digression and look at the input function for getting input from your user. And then we'll look in more detail at types of variables. We'll look at testing conditions with if statements in Python. And finally, and this is unique to this video, we'll look at what comes next in your learning. So let's get started. So this tutorial could have been called Owl Stretching Time, because that was one of the original names proposed for Monty Python's Flying Circus. But wiser heads prevailed, and I'm pleased to say I'm now teaching you Python instead. The language was first created and developed by Guido van Rossum. My sincere apologies if I've mispronounced his name. The first thing to do is to see whether it is installed on your computer, and the instructions which follow are actually specific to Windows just for this one section. So to do that, I can go to the Cortana search bar and I can type in programs, and then if you execute that, you should see whether you have Python installed. So what I'm going to do is search for Python, and you can see I've got the latest version at the time of speaking, 3.9.6. I've also got something called the Python Launcher. And what I'm going to do is uninstall both of those two programs behind the scenes, and I'll see you again in a short while. You can see now that I've successfully uninstalled Python. There's nothing showing the list for it. So what I'm going to do now is to show you how to put it on your Windows machine. As I said, this is one of the few bits specific to Windows. So I can go to a search engine. I've chosen this little known one, and I'm going to run the install Python search, and almost certainly the first results returned will be python.org. And this is a website which you're going to become familiar with as you learn more about Python. So I'm going to click on the button to download Python. I'm downloading the latest version at the time of speaking, 3.9.6, and then I'm going to run that executable file. And what that will do is begin the Python installation process. Now the first thing I'm going to do is tick this box which says add Python 3.9 to path. And the reason for that is Python is absolutely terrible at managing paths, and anything I can do to make the process easier has to be a good idea. And then what I'll do is show you how to customize your installation, just to prove that you probably don't need to do it. So all the things here you probably want. You want documentation, why not? You definitely want to be able to use the pip installer to install modules. We're going to be using the idle development environment very shortly, and tkinter will allow you to create your own graphical user interface programs when you'll become more skilled in Python. You probably want to be able to run your own tests at some point in the future. And the PyLauncher is an extra utility, making it easier to run Python programs from the desktop. It's not terribly important, but you might as well install it. So we're just going to go back and install Python by clicking on this button. It will ask me to confirm that and start installing. So you can see that my setup was successful. That's good news. I can close that down. And if you go and look at your list of programs, you'll see it's reinstated, in my case, the Python programs. So I'm all set to run Python. So before you can write any Python at all, you need to choose an integrated development environment, or IDE, which is a really fancy way of saying somewhere where you can type your code. So one possibility would be Notepad. And what I want to do now is show you why this would be a terrible choice, just because I think it throws light on what would make a better one. So I'm going to type the print command in Python. It's a valid Python command, but Notepad isn't giving me any help at all. And even if I try typing a message, there we are, message, in brackets, I still get no help. Not only that, but it's not possible to run the command in Notepad. So for various reasons, Notepad wouldn't make a good choice. So what would be a better one? Well, let's close Notepad down just for the moment to get it out of the way. 3 possibilities would be PyCharm, Spider, or Anaconda. And I've grouped them all together because they're all specific to writing Python. You can't use them to program in any other language. And they'd all be perfectly good choices. Another would be Visual Studio, slightly over the top, a big beast which you can use to develop websites and all sorts of other things besides. Or you could use Visual Studio Code, which despite its name isn't actually the same program at all. And that's the one we're actually going to be using later on in this tutorial. But for the moment, we're going to use idle. Now idle is built into Python, that's its great advantage, so we can get up and running programming straight away. It stands for the Integrated Development and Learning Environment, and it was named after Eric Idle. That's him there. He was one of the original 6 Pythons, the other ones being from left to right Terry Jones, Graham Chapman, John Cleese, Terry Gilliam, who did the animations, and Michael Palin. So to run idle, you should be able to just go to it as a program installed on your computer. You can see it's nestling there, waiting to be run. And what I'm going to do is open that up and type in my first command. So you can type in any command, or do the same one pretty much, by typing in the name of the command followed by an open brackets. And you can see the advantage that I have a list of all the arguments, that's what these things are called. They won't make much sense at the moment. And I also get the print word is color coded, so I can see I'm on the right lines. I'm going to print out the noise an owl makes, at least in the UK, which is twit. And I'm going to close my parenthesis, and I press enter to run my command. You can see the output appears in the command prompt. That's how you can type single line commands in idle. What would be better is to be able to create a series of commands to print out, for example, twit to woo as 2 separate lines. And to do that, we're going to have to learn how to create new files in idle. So I'm going to create a new program to hold 2 command lines to print out the words to wit and then the words to woo. Very ambitious. So to create a new program, you can choose File from the menu and choose New File, or you can press Ctrl-N to do the same thing. You can then type in any command you like, but I'm going to begin with a comment. Comments begin with a hash key in Python, and the advantage of them is that you can explain what you're trying to achieve, and anything you type in will be completely ignored by the Python interpreter. So I'm going to put a comment saying make owl noises, quite a descriptive term for what's about to happen. And then I can type in my first command. So I'm going to put print to wit. That needs to go in inverted commas because it's a string of text to be displayed. I'm then going to press return. I'll press return a couple of times so I get a blank line. Blank lines will be ignored by the Python interpreter, so they're just for spacing really. And my second part of my command or my program is to say to woo. So that's my complete program. I can run it now, and to do that you can choose Run from the menu and then choose Run Module. Pressing the F5 key is actually a much quicker way to do the same thing. When I run any program in idle, it will always insist that I save my file. So I'll do just that, I'll click on OK, and I'm going to save it in a location I've already created and lined up called Wise Owl, and I will call it Make Owl Noises. You can see it will assign a py extension to it to signify the fact that it contains Python code. When I save it, 2 things will happen. It will create the file on my disk, but it will also run it because that's what I chose to do. So I'll get the output of my program in the Python command shell, to wit to woo. And that's how you can create simple programs in Python. I'll just close that back down and show you one more thing though. Let's just get rid of that blank line and run it again. When I run it a second time, it will again ask me to save my changes and again give me the output. But what I was going to show now is how you can comment out lines of code. So what I want to do is keep these lines in for the next part of the tutorial so that I can refer to them. But I don't want them to be part of my executable code, as it's called. So to do that, I can choose Format from the menu and choose Comment Out Region. If I want to undo what I've just done, I can then choose Uncomment Region, which will reverse the process fairly obviously. When you choose Comment Out Region, what you'll get is hash symbols before, double hash symbols before each line. So the lines are still there, they just won't form part of the program. And what we're now going to do is look at the all-important concept of variables in Python. So what are variables? Well, one way to look at them is as suitcases. Bear with me. So for example, you might have a variable to hold the name of a film, and you might designate that it should be called film name and should hold only text. And you might have another variable to hold the number of Oscars the film has won, and that you might call Oscars won, and that would hold integers. But the suitcase analogy only goes so far, so let's have a look at some real variables. So here's the meaning of life in 3 different languages: Visual C#, Visual Basic, and SQL. And they've all got something in common. In each one of them, you create or you designate the type of data the variable will hold. It's an int in C#, integer in Visual Basic, and int again in SQL. So how does that differ from Python? Well, in Python, when you create a variable, you'll see you don't give it the data type. And this is something I've grown to love. Why waste time declaring the type of data when you don't need to? As we'll see later on in this tutorial, Python does care very much about data types. It just doesn't make you declare them yourself, it sorts it all out for you, which is typical of the Python language. So let's go back to idle and have a look at creating some variables. We're going to write exactly the same program, but this time using variables. So our first variable we're going to call owlNoise1, and what that will do is refer to the first noise an owl makes. So you can see there that when you create a variable in Python, firstly, the convention is that it should be in lowercase. And secondly, when it's a compound word, the convention is to use an underscore to join the different parts of it together. So that's my first variable. And my second variable I'm going to call, somewhat predictably, owlNoise2, and I'll set that to be to-woo. So I've got my 2 variables, and what I now want to do is print them both out again. So I can put a print command. The first variable I'm going to type in is owlNoise1. And you'll notice I'm not including quotation marks, because if I did, I would just get the text owlNoise1 rather than the value of the variable called owlNoise1. You'll also notice that idle isn't giving me any help. It could, for example, come up with a list of possible variables for inclusion in my code, but it's not doing that. And that's one of quite a few reasons why I want to move on to Visual Studio Code in the next part of this tutorial series. So what I'm now going to do is put a concatenation symbol, it's a plus, and what that will do is join 2 bits of text together. The next thing I'm going to type in is some joining text, because rather than getting to-woo, I want to have it separated with a comma. And finally, I can put the value of my second variable, owlNoise2, and complete my command. So hopefully when I run this program, it will do more or less the same thing. Let's see if that's true. So if I choose run module, and if I save my code, then when I choose OK, you can see I get to-woo. And you can see there the comma space I included as a separator between the 2 parts of the output. So I'll close that back down. And that completes this look at variables. What I now want to do is to take a brief digression and look at the input function, which is how you can get input from your user. So what I now want to do is to ask the user what their opinion is of the meaning of life and then display that back. So let's put a comment in to explain where we're going with this. Ask user for meaning of life. And then we'll create a variable, which I'm going to call meaning. And what I want to do is solicit from the user what they think the meaning of life is. And I can do that with the input function. As the arguments suggest here, it takes a prompt, which will be displayed back to the user. So I'm going to type in, what is the meaning of life? The archetypal question. And then I'll close my brackets, press return. And what I can now do is try running that program. So I'll choose run from the menu and choose run module. And as always, it will ask me to save my file first. So I'll click on OK, and I'll call it meaning of life. And then it runs a program. You can see that my prompt is a bit close to my answer. I could do with a few spaces there, which we'll add in a second. And when I press return, nothing happens. It doesn't redisplay that back to me. So we'll make those 2 changes. So to add the spaces in, I need to do them within the inverted commas. It's no good putting them after that because they'll just be ignored. And then to Play the information back. So display result. I can put a print command, and what I'm going to do is type in some preamble saying the meaning of life is, and I think we could do with a bit of tension here, so I'll put 3 dots there. What I want to do is display the meaning of life on a separate line, and to do that, and incidentally, if you're wondering what this is, it keeps popping up in idle for no obvious reason. So if I type in \n, the backslash is an escape character, and it says that anything following that should be ignored, or rather should be treated differently. So n means a new line character. If you're wondering how I put a backslash in, I would just put two backslashes, one after the other like that. So that means a new line. I'll then put a plus in as a concatenation symbol, and then I'll display the meaning of life after that as typed in by your user. And that is a complete command. I can try running it. It will ask me to save it. I'm going to type in the meaning of life. What would it be? Let's keep to 42. And then if I press return, you can see I get the meaning of life is, and I get the 42 there in a separate line. Just about there, there's a \n character throwing a new line. So after that little digression on the input function, what I want to do now is go back and look in more detail at how Python handles the type of variables. So to look at data types of variables, what I'm going to do is something fairly harmless, it would seem. I'm going to double the meaning of life. So I'm going to take the previous meaning of life and set it equal to be what it used to be times. So instead of getting 42, I should get 84. Let's see if that's what's happened. If I run my code, type in 42 and press return, I actually get 4242. And the reason I get that is because this input function always returns a string of text. I can prove that in 2 ways. The first way is if I type that bracket back in again, it will bring back up the auto-completion. And you can see that it reads a string from the standard input. So whatever you type in, it will be returned as a string of text. And the second way I can prove it is by adding an extra little line of debug. What I'm going to do is use the type function to get the data type of that variable, and then print that out. So if I run my program again and type in 42, you can see what my problem was. The variable, don't worry about the word class, we'll come to that much later. For the moment it just means what sort of a thing it is, but you can see it's an str, it's a string. And so what Python is doing is when it hits that star character, if the thing preceding it is a string variable, instead of assuming it's doing arithmetic operation, which would be impossible, it just assumes it's repeating it as many times as you put there. And that's why you're getting the rather strange message. So to get around this, what I'm going to do is convert the data type of this variable I've just typed in from what it was, a string, to an integer. And then I'll be taking one integer and multiply that by 2. And that, I hope, will solve part of my problem. The best way to think of this is that there's 2 versions of the meaning variable. There's the original one, which was holding a string of text, and then Python creates a new version of it, which is actually holding an integer. So at no point does the same variable hold 2 different data types. If I try running that, and type in 42 and press return, you can see that it has not solved my problem. I've got an additional one. What it's trying to do now is concatenate a string with an integer. So I've half solved my problem. The problem lies in this line here. The thing it's printing out consists of 2 parts. The first part there is a string of text, but the second part is now an integer. And you can't mix strings and integers like that. It won't automatically convert the second thing to a string for you. Some languages will do that, Python won't. So what I need to do is the absolute opposite of what I did before, and I need to take my integer and convert it back to a string of text. And with all those pieces in place, I'm hoping that when I run it this time and type in 42, I will get the meaning of life as 84. And that's how data types and variables work. We've learned 2 important things, I think, here. One is you can use the type function to investigate what sort of information a variable holds. And the second thing is you can use the int and the str functions, and there's others as well for different data types to convert things to integers and strings. So every language has the ability to test conditions with an if statement. Here's how it works in Python. The syntaxes are shown there. The condition is anything which is evaluated to either true or false. And following that, you have to have a colon. On the next line are all the statements which are executed if that condition should turn out to be true or not, or if it's true rather. So Python will execute all of the statements which follow on, provided they're indented, and it's that indentation which I really want to draw your attention to. Python is, I think, the only language I've seen anyway, which relies on indented code to say whether something should execute if a statement is true or not. It's a nice, elegant way of, again, reducing the amount of typing you need to do. At the end of your if statement, you could have additional lines of code, and they will execute whether the if statement was true or not. And that's because they're no longer indented, they're flush up against the left margin. So that's how if statements work. Let's have a look at a practical example. So I'm going to go back to Python. I'm going to clear my if condition. And I'm going to test which house people belong to in Hogwarts. Now, if you've no idea what I'm talking about, you need to watch more Harry Potter books or see more Harry Potter films. But the meaning of it, I hope, will still be apparent. So I'm going to create a variable to find out the name of somebody. I'll call my variable who, and I'll ask the question, who are you? Another profound question in this series of tutorials. And then what I'm going to do is test who they are. And if it's Harry, I'm going to assume that they're in Gryffindor. If it's Cedric, I will assume they're in Hufflepuff. Draco will be in Slytherin, and Luna will be in Ravenclaw. You can see the huge amount of research which has gone into making sure this runs smoothly. So I'm going to test the name and see a Wise-Owl version of the sorting hat. So to do this, I can put an if statement in. And my condition will be if the name I've just typed in equals Harry. Then put a colon to say that's the end of my condition. And if that's true, then I'll print out Gryffindor. Again, you have to have seen the film to understand that. So now if I try running my program to check that I get Gryffindor, I need to save it first, so I'll call it sorting hat. And when I run it, I get an invalid syntax message. And the reason for that, and I can only apologize for this on behalf of Python, is there's two ways you can use an equal sign. If you're just assigning the value of one thing to another, you use a single equal sign. But if you're testing whether one thing equals another, you have to use two equal signs, one after the other. And I guarantee that you will fail to do that time and time and time again if you're not used to it, and keep wondering why your program is going wrong. So please do try to remember that. So hopefully that solved my problem. If I now try running it again, and if I type in Harry with a lowercase h, notice that, and press return, I don't get Gryffindor. And the reason for that is I've got another bug in my program, which is this. Python is always case sensitive when it's comparing two strings of text. Who contains Harry with a lowercase, but this is Harry with an uppercase. They're not the same. And the standard solution to this is to make sure I'm comparing like with like. So what I'm going to do is turn the right-hand side of the equation to lowercase, and I'm going to make sure that whatever I type on the left-hand side, that is also in lowercase too, using the lower function, which takes no arguments. Now, I suspect that probably didn't make a huge amount of sense, but we will get onto string functions later in this tutorial series. For the moment, just accept that will turn whatever you type in the variable into lowercase. So now if I run this yet again, and this time, just to prove that this is going to work, I'll have Harry with a mixed case like that. And when I press return, sure enough, Harry is in Gryffindor. So that's a simple if condition. I, of course, now want to test all the other people. So what I'm going to do is cheat slightly and copy and paste this next line. And make sure I get my indentation right. And I need to put elif there. Elif stands for else if. So when I'm testing an alternative to the first condition, I have to put elif. My second condition is going to look for, let's go for Draco this time. and Draco will be in Slytherin. And then I could repeat this twice more. And test for Cedric, who, as we all know, was, and I have to say I do mean was, in Hufflepuff, and Luna Lovegood, who was in Ravenclaw, and for all I know still is. There's one more thing you can optionally do with an if condition, you don't have to, which is you can add an else condition. And what I'm going to say is, if it wasn't Harry, Draco, Cedric or Luna, then I'm going to display a message saying, no such person. Then just to complete the picture, I'm going to print out a message saying, sorting complete. That will display whatever I type in. So that's the full syntax of an if statement. So what I can now do is run that. I'm going to run it a couple of times. I think the first time I'll go for Luna. She's one of my favourite characters, and press return. And you can see it says it's in Ravenclaw, and I get sorting complete. So let's try running it again. The next time I run it, I'm going to type in somebody who definitely doesn't exist. Andy, that's me. I'd like to be in Gryffindor, who wouldn't? And when I press return, it just says no such person. And that's because it failed all of these conditions. And so it wasn't any of those things, so I got to the else at the end and it printed out no such person. You don't have to have all the else clauses. This will work perfectly well if I took them all out. I could just have an if and an else if. So if I comment out that code, it will still work. But if I type in Luna now, because Luna was part of the commented out conditions, I'll just get no such person. And that is pretty much it for how you can put if statements in Python. I think it's worth mentioning just one more thing. Many programmers in other languages will have seen equivalents of the switch statement or the select case statement. That doesn't exist in Python, so don't bother looking for it. You have to do it with an if condition. So I want to end this section with a rather strange plea of what to do next. When I was teaching myself Python, I found that the learning the language was relatively straightforward. It's quite a fun language to learn and very powerful too, and compared to some other languages, easy to use. But getting it set up, that was very different. At some stage very soon, you are going to have to stop using idle. It just isn't powerful enough. And you're going to, like me, have to run a search for Python code editors. And what you'll find is it comes up with sites listing the 9 or the 12 or the 10 best Python code editors, and you'll be forced to choose to invest some of your valuable time in learning one of them. So which to choose? All I can do is tell you why I think Visual Studio Code is probably the best choice, but obviously different opinions will be different. So some of the things that you can do in Visual Studio are debugging, stepping through code line by line to see where an error lies. Syntax highlighting, which means highlighting in different colors where you've used different Python parts of syntax. And intelligent code completion, which is where Visual Studio will suggest ways of completing your Python commands for you, which is very useful. And there's some others listed there as well. You may find it reassuring that Visual Studio Code is popular with Stack Overflow users. Personally, my reasons for choosing Visual Studio Code were that it's easy to use, it's very powerful, it's similar to Visual Studio, which I also know. It's made by Microsoft, which means it's got the backing of a software company, and it seems, along with PyCharm, to be one of the most popular choices on the internet. But my plea to you is to stick with this tutorial for the next part of it, in which we're going to install and set up Visual Studio Code, because you'll have to set up some IDE. And then I promise that when we get onto the third part of this tutorial series, we'll resume writing Python programs again and we'll start doing useful stuff.